Hello everyone! Back in 2017, when Minecraft version 1.12 was still the current version, I made my own re-implementation of Redstone Wire and update order of Redstone components. I worked on it again in 2019 and also updated it to the then current version Minecraft 1.14.4. And what you're seeing here is actually this modified version of 1.14.4. Now, since I lost the original 1.12 version, the exact timeline is not 100% clear, so I don't know when exactly I started working on it. I do know that I worked on it for 1.12 in 2017 though, because I found a old world that still was from 2017 where I did some testing with my implementation. Now, a lot of the concepts that I implemented here are actually based on the work of Panda. So, back in the day, Panda4994 made a video where he was talking about different symmetries that we would like Redstone to follow. And to summarize, essentially what we want is when we build something in one location, it should behave exactly the same if we build it somewhere else, and it should also behave the same on different devices, and yeah, just be reliable. And then we also would like to, when possible, to have it follow a rotational symmetry so that you can rotate a design and it still works. And we also, when possible, want it to be mirrorable, so you can mirror it and it still works. Now, this is not always possible unless you introduce randomness, and in this implementation there is no randomness. Now, the videos by Panda are linked in the video description, and there is also two where he showcases his own re-implementation of this exact logic, which, however, as he points out in his second video, still has some flaws and is mostly just an experiment by him. And in his video in his initial video about his modification, he also talks about how Redstone Wire behaves in the vanilla game and what the actual issues with the update order and the update behavior in general is. So if you're not familiar with that, I recommend watching this video to actually understand the problem that we are trying to solve here. And now, since Mojang recently also started experimenting with Redstone and in a recent snapshot added some experimental changes to the update order of Redstone, I thought now might be a good time to talk about my own implementation, highlight some of the benefits that it has and also some of the flaws, and also give some insight of what I think that the final implementation by Mojang should look like. And yeah, maybe this is helpful to Mojang, maybe it's also just interesting to some people who looked at the implementation by Mojang and don't really understand some of the design decisions they made. And yeah, I guess let's get right into it. So to start, I will change this value, and what this does is it adds some delay to Redstone Wire, as you can see here. So this is a little debug feature which showcases how the game determines which signal strength each individual wire should have. Now, these updates that you're seeing here are usually not actually happening in game. So when I flick this lever, these updates do not happen server side. There are just some additional packages that the server sends about block updates that don't actually happen, to have like this debug showcase where you can see a little bit behind the scenes. And what is actually happening here is that the game determines which signal strength each individual wire should have. And then at a later point it would actually change the wire and cause updates, but this only happens when the final signal strength has been determined. Now when turning it on, this is actually quite simple, because we just need to set the redstone wire to the strength that it should have, and we have each individual wire already has all the information that it needs to determine the strength that it should have. When turning it off, this is not always quite as simple, and as you can see, the game already assumes that all of these wires should be turned off, even though it doesn't necessarily know that. If you imagine that there's another signal source in the system, now this wire here would start at 15, and then it would need to be changed down to 1. But just looking at this wire, when this is at 15 and there's 14 over here, we have no way of knowing this. When turning it on, it's a little bit simpler, because we can just set it to either the power level that it should have according to the power source that got updated, or if it has a higher signal strength already, then we know that there must be another signal, another source in the system, and we don't need to change anything, and we can just keep the old strength. Now when turning it off, we also initially assume that we have all the information, but then when we see that we don't, we correct ourselves. So let me show that again. So as you can see, if I flick this lever, initially everything starts to turn off, and then when it hits this wire, it realizes that this wire has a wrong signal strength, and it propagates this information. Over here, when this wire turns off, it sees that this wire here has signal strength 14, which makes sense. If this is 15 and this wire is powered exclusively by this level, then this should be 14, so we can assume that we have all the information and turn this off. And then when we realize we were wrong, we just correct and propagate the information that there must be another signal source down to all other wires. And I can also show that a little bit more slowly in a more simple example over here. So as you can see, when turning it on, it's pretty simple. It just turns them on in order, and then so if I add another signal source, the same thing happens. But then when I turn it off, it initially turns them off completely, and then over here, when it realizes that this wire has a wrong signal strength, it propagates this information down back to here. Now the way I implemented this over here is with a graph. So what this means is, when I flick this lever, all of these 4 wires that are connected to the lever will be added as root wires, and then they themselves will look around and see if there are other wires that are connected to them. And then this wire will see that these 2 or these 3 wires are connected to it, so it will store this information and store the information that this wire, and this wire is connected to here, and these can receive power from this wire. And then likewise, this wire would then add all of these 4 wires as its connected neighbors. Now the advantage this has is when there's a lot of backtracking going on, like over here, we only ever need to look at each individual wire once, and we need to only query each wire once and query the block state only once, and also only look at what neighbors this wire has once. And then we have this information, and even if we need to update a wire multiple times, we can just rely on the information that we already have, and we can just do all the changes in memory without needing to do any block lookup in the chunk. So yeah, that's the advantage that this graph implementation has. Potentially, you could also think about actually persisting this graph. So if you imagine this being some sort of data structure, we could think about caching it or even storing it in the chunk data. And then if we have it stored and we add some wire, then we would just update the data in the chunk, and then when some update happens that is related to any wire that is part of this graph that we just stored, we would just retrieve this graph and perform the update. Now, this is something that is not implemented here, and with how I implemented the graph, this is actually also not really possible, because there's a lot of state that is just related to the current update that is happening, which are stored in each node for each wire, and because of that it's not really possible to persist it. But yeah, it would be quite nice if it was possible. And yeah, if I would re-implement this again, there would definitely be some changes that I would make to the structure, which would maybe make this a little bit easier. But yeah, since this is code from 5 years ago, it would be actually quite depressing if I was completely happy with it, because it would mean that I didn't improve at all, basically. So yeah. And now there are also some issues with this implementation that are more noticeable in the game. So if I have some slab wire, or so like the way this works is, because this is a transparent block, if I update this wire, it can provide power to this wire, and it can and this provides to here, and this provides power to here, and this wire also provides power to up here, but not the other way around. So this wire can receive power from over here, but it does not provide power to this wire. And if I turn that on, you can see that the evaluation kind of makes sense. So we go from here down to here, and then at the end of the day this has power level 12, which is what we would expect. But when turning this off, you can see that it does like this weird loop here during the evaluation. And you can imagine that if you have a lot of this, and maybe even a diamond shape that has a lot of slab wire in it for some reason, then this would actually be quite expensive to evaluate and not very ideal at all. The reason this happens is because this wire sees that it receives a signal from here, and at this point there's no way of knowing that this connection here exists, and the reason this is power level 12 is actually because it is receiving power from here. There's just no way of knowing this. Now potentially we could know this if we would build the entire graph before the evaluation happens. So we could see, okay, there's a wire here which is connected to here, which is connected to here, which is connected to here, and then we could maybe see this. But what's currently happening is that during the evaluation the graph is also built at the same time. And if we would see that this wire is actually part of the graph, maybe we could avoid sourcing a power level from here, but it could potentially also have some other issues if we just completely ignore this wire here, and I'm not sure that there is actually a good way to completely prevent this. but yeah, I haven't experimented with it that much, and in this implementation you can see that this is still an issue with SlabWire that persists, and there were actually a lot of bugs and issues that were caused by SlabWires where the wire wouldn't update correctly because of the graph implementation, and it was actually quite hard to deal with it because suddenly you have a directional graph instead of a graph that works both directions. So yeah, that was a bit challenging anyway. Now you also might have already noticed that this looks a bit weird, like this is a line, but it's somehow connected to here, and this looks like it's connected to here, but this one isn't. And yeah, this is just because of the way that Minecraft 1.14.4 works. So also if you would place this in vanilla 1.14.4, this would actually be a dot. So if I go into vanilla 1.14.4, so if I just place a wire here, it will just be a dot, but it still behaves like a cross. And that's something that I changed in my mod, and I essentially made the wire look like it also behaves logically. And over here, this wire actually looks like a line, but it still powers this lamp over here, and actually also powers this one. And the reason for that is this wire behaves like a cross. And if I were to place another wire here, it still powers this lamp, but now it doesn't act as a cross, it actually acts as a line. And the reason for that is it ignores the wire up here. So it essentially logically behaves like this. And the reason for that is it only connects to wires where it can receive power from. So this wire cannot receive power from here, so logically it doesn't connect to here, but this wire does receive power from here, so it logically does connect and logically does form a line, so it doesn't update this lamp. And then over here, if I add another wire here, of course this now does not power the lamp, because even without this wire this would be a line and also act like a line. And then could also do this, and now this would behave like a curve, but it doesn't look like it. And I sort of address this issue in my mod where the wire actually looks like the way it behaves in 1.14.4. And so we get some quite cursed looking things like this one, where there's a cross, but also it goes up this block, and yeah, it does power the piston. And then also things like this, where this is all working slab wire, but it looks a bit weird. And of course, since 1.14.4, Mojang also addressed this issue, and when placing redstone in modern Minecraft, it looks like a cross again, and like this still looks like a line, but it also behaves like a line. So Mojang actually opted for changing the behavior, where I opted for changing how it looks. But you can see why they maybe decided to change the behavior instead, because this looks quite cursed. Okay, now let's talk about how updates work in this mod. So this redstone wire here causes a redstone update to this piston, but it doesn't update the water. And if I cause a normal block update, it still causes a block update, and the water does flow down here, but this does not happen with a redstone update. And now this over here, at least usually I like this game rule is true by default. I just changed it for previous testing. So this still updates the piston, and there is a third kind of update. So there's plug updates, there's redstone updates, and there's quasi connectivity updates. And this is just to preserve old behavior. So this wire actually does update the piston with a QC update. And when this kind of Redstone update happens, one of the advantages this has is obviously other blocks that don't really react to Redstone, they don't do additional checks, so this water just doesn't react to that. Another thing that this does is this actually also gives some meta information to the blocks that it updates. So this piston from the wire would receive the information that it is receiving power level 15, and since it is retracted, it knows that it should just extend, and then this would cause a redstone update with power level 15 here, but it is already extended, so it doesn't change at all. And yeah, it basically allows for some optimizations. Of course, when turning off, we can't just retract the piston because, and here we actually do need to check for other signal sources to make sure that we can extend, that we can retract, and here we actually can't. But here we would see that we actually need to retract. Now, pistons actually are a bit special because if I do this and then cause a block update, it actually updates the piston. This is just to preserve old behavior, but if I set block, a redstone lamp here which is lit, and cause a block update, it actually does not update. And also this doesn't update it, and only if there's actually a redstone update, it does turn off. Now there are some disadvantages to that as well, because as you imagine, when you place a block here, this still needs to receive a redstone update. And the same also when you move the block. And the way I did this is, whenever you place any block in the world, it needs to check if it's being powered, and if it is being powered, it then causes redstone updates. Now, since most of the time the block will actually not be powered, this check is usually unnecessary. So I think in this regard, I actually like the current behavior where a block update would also update redstone components, and then if they receive a block update, they just check. At least one optimization you could do is you could look at the direction the block update comes from, and when it comes from up here, this comparator could know, oh, I can't receive power from here, so it wouldn't update. But in the general case, I think that this, in hindsight, is maybe not the best way to approach this. I can also visualize the updates that happen. So if I place a block now, you can see these blue boxes, and blue means it's a block update, and then red means it's a redstone update, and green means it's a QC update. So as you can, so if I remove this piston, you can see that there's a green update down here and no red update. And then also, if I remove or place this block, you can see some purple updates here, which are both a block update and a redstone update. So blue and red just make magenta. Now, for visualization, it is actually nice to turn this off, because they are just, the green updates just kind of overtake everything, and now you can see there are only red updates here because we turned off the QC updates. Oh, and I should also mention, QC updates are much like redstone updates, so only blocks with QC behavior actually react to them, and water, for example, wouldn't react to it, or the redstone lamp wouldn't react to it. It's just that pistons and dispensers react to it, and droppers, I guess, as well. And with this being set like this, we can also do the big thing and see, in fact, that there are only updates caused in blocks that receive power from it, or used to receive in this case. And this is actually also necessary because, as I said, when I flick this lever, this piston actually receives the information that it is receiving power level 15. So if I cause the wrong update, then this would actually be very problematic. Now this debug window you're seeing here is actually also present in the vanilla game. It's just not accessible, and I just modified it a bit to distinguish between different kinds of updates, where in vanilla of course there's only one kind of update. And there's also the number of block updates that have been caused in this block, which is this top number here, and this is also present in vanilla. And then the bottom number is, I think, related to the priority or the timing when this update happened. So the higher the number, the later the update happened. Now you can see that this block actually did receive 2 updates, and this one received 3, and over here there was one with 5, and 5 is actually the maximum that I could find. So all of these receive 5 updates from different wires, because essentially like this wire powers the block below, which is a barrier block, which is a full block, and then the barrier block also powers this barrier block and the block below and such. So you could, and I think this actually might be something that would be worth it, but I did not do it in this implementation, is to try to reduce this to the absolute minimum so that there would be only one update here, and it would happen from the wire that first sees this block and not from any other wire. And I think this actually wouldn't be problematic, since I'm already distinguishing between normal Redstone updates and QC updates anyway. If this distinguishing was not done, which is currently also not done in the experiments by Mojang, then this could lead to some weird effects where you update a block which isn't actually receiving power yet. So you would need to probably still cause at least 2 normal updates in that block, just so that the QC update happens, and then if it actually does receive power later, then it should also be updated at that point. Although I think I also have heard that maybe the implementation by Mojang actually sets all the wire block states first and then causes updates. I'm not sure if that's true, but if that's true, then that might be less of an issue, but it might also cause some weird effects with the actual order updates happen in, as here I actually set the wire and update the blocks at the same time. And yeah, and that was usually quite, so I didn't really find any weird behaviors with this approach. But I might have missed them as well, I don't know. Okay, so let's turn this back on and talk a little bit about the update order. So the update order is actually very, very similar to what Mojang did in the recent experiments, and I was actually very happy when I saw their initial implementation in 24W33A. So let me turn that off. So if I flick this lever, this piston is updated first because it receives power first, and the same over here. So it depends on which lever I flick, which piston updates, which also means this is rotatable. So I could rotate this by 180 degrees, and it would still work the same way relative to the lever. Now I don't have any randomness in this mod, so if I flick this lever, the left side is always preferred, which means that also all of these designs are rotational, so they can be rotated. And also over here, this is a bit different from Mojang. If I flick this lever, this piston is at the front, so it updates first, and this piston is at the back, so it updates second. Mojang actually has those two flipped, but then it's the same again, so after doing front back, I do left right, and then I think maybe up down or down up. I'm not quite sure about that. But yeah, this is very similar to what Mojang does, and it's just that Mojang decided to prefer back over front, which is just basically an arbitrary decision that I made here. I'm not sure if back front maybe has some nicer behaviors in some cases, or if it's just also arbitrary by Mojang. Now about the randomness that was introduced in 24W33A and then removed in 34A. I actually didn't think that this was too much of an issue. And for that, let me switch to here and replace these with normal dust for now. So if I now flick this lever, so you can see, hopefully, yeah, the update order is random. So we get some rights and some lefts. However, every single time, so this one, pick the left piston, left piston, left piston, left piston, and if the right piston is picked, then it's also always the right piston for all of them. So there are essentially only two possible states this contraption can produce, which makes it quite easy to debug and find issues by just testing it a bunch of times and see that it works. And there are some issues with this, and if I add a delay here and flick this lever, now you can see that this decided that it should update the right one, and the others in this case decided that it should be the left one, so this does not have the same behavior. And essentially, because there's this delay here and the tile tick does not store the information from the lever that which of left or right should be preferred, so over here a new random choice is made. And yeah, and this is definitely something that if the randomness would stay, that they should address. However, I think that they should fix this behavior with tile ticks anyways, and there are some cases that still apply in the current version, which I will show later. Now, something that Mojang also doesn't do, but they address this in the changelog of 33A, is they only changed redstone wire. So if I flick this lever and then rotate it, in my mod the update order of this lever also rotates. Now this means that some things that rely on the existing update order will break, because in the current version of the game, when there's a block update caused by, for example, a lever or a pressure plate or some other component or piston moving, then this will always update in a fixed order according to the coordinate grid. So it would update north first and then south and then up and then down and then west and then east. I'm not exactly sure if this is the exact order, but it is something similar like that. So existing things that rely on this update order would break, but I think that this update order is better because it respects the rotational. So it means that essentially if you rotate something, it always works the same if possible. And then there are some cases where it's actually not possible, like over here, where we just have the pressure plate as input. And there's actually no randomness here, that was just caused by this piston being on cooldown, so that piston briefly extended here. But yeah, there's no randomness here, and if in Mojang's current implementation this actually would behave randomly, and yeah, so this is still a case that behaves randomly. And in my version it just prefers updating north first and then the south and then west and then east. So essentially north is front and then south is back and then west is left and then east is right. So this is how it behaves in my mod. But Mojang decided that they prefer it being that everything is possible to rotate, so they decided that they introduce randomness here. Now there is an issue with the randomness that Mojang uses, and also this is also present in my mod. So if I turn this on and change this torch from over here, you see that the right hand piston extends, and then if I rotate the design, then I need to fix this, and if I rotate the design, it's going to be the left piston that extends, and this is not possible to rotate, even though there's nothing here, which means that it in principle would be impossible. And the reason for that is that this redstone torch does not keep track of from which orientation it received the power, and doesn't store that in the tile tick. So this is something that in my mind still needs to be fixed with Mojang's current implementation anyway, and this is also why I'm not so worried about the behavior with repeaters, where it would cause a potential exponential problem, where you have an exponential number of possible states because you have different delays here. Now, if you have a random update order in this case to make sure that a design can always also be mirrored, but the tile tick does remember which of left or right is preferred. This would also mean that if you have, for example, a repeater clock, then if you turn on the repeater clock one time, it would always maybe be preferred the left side, but it would, because the repeaters are powering each other, it would keep that information alive forever. And then if you turn off the repeater clock and then turn it on again, then it might change to be the right side, which would also be quite interesting, I think. And like I don't mind this not being random too much. Personally, I did actually prefer it, but many people of the community didn't like it, so Mojang changed it because of that, which is also fair. Like this being not mirrorable, I think is also totally fine. And it's also going to be interesting to see if they also make this being not possible to rotate by removing the randomness here. But I'm not sure what the community thinks about this, and this is quite the edge case, and you actually have to try quite hard to have randomness in Redstone Wire in the latest situation. And even this is a pretty edge case, but it is a bit easier to produce, at least. Now, something interesting that my mod actually already does correctly, if I flick this lever, you can see that the redstone block is being pushed here, and the left piston extends. And then if I rotate the design, it's still the left piston that extends. So this redstone block actually gets the rotation of the piston and then applies the updates accordingly. And now this is actually not related to how the redstone block moves, but how the piston is oriented. So if I have this where the retraction actually causes the update that extends the piston, it's still the left piston. I think it would make some sense to actually have it the right piston here, because the redstone block moves this direction, so this should be the left side. But it's also fine if it's the left side. I think I would prefer to behave the other way, but it's not implemented that way apparently. And yeah, you can, however, also rotate it, so it's still the left piston if you rotate it. There are some issues with this implementation, so if I flick this lever, you can see it's this piston and this piston that extend, and then if I rotate the design, it's still the same two pistons. So the piston does not transmit the information about from where it received power to the block that is being extended. And yeah, it's actually quite interesting to me that I have this part of the mod but not this, because I think this is with tileticks is actually more important. And I also know that I at some point messed with tileticks, but it doesn't look like it made it into this version of the mod. I don't know if there were maybe some issues that I had, or maybe it was just a bit more complicated and I didn't get around to porting it to 1.14.4. I'm not quite sure what happened here, but I definitely do remember messing with tileticks and actually also fixing this issue, but it is not being addressed in this version of the mod. Now, something else that I don't like that much about the update order is this. So this this lever updates this block first before the block up here, which makes sense. But then this block, because it's a solid block, relays that information and also updates all blocks around itself, including this piston. So when I flick this lever, this piston is updated before that, even though this piston is further away from the lever than the piston above. And that's something that I think would ideally work differently, and it would actually extend the piston that is closer to the lever here. So essentially how I would prefer the update order to be is still the front, back, left, right, up, down. But then after that, this solid block then causes the updates to all its surrounding blocks and not before all the direct neighbors of the lever have been updated. But yeah, this is not the case over here. And you can also see this behavior with wire. So if I turn the evaluation delay back on and flick this lever, you can see it updates this first and then this and then this and then this, and not and these two are updated last. So, and what I would prefer is if this lever updates this first, then this, then this, then this one, then this one, and then this one. And if you look at this pattern, it actually still looks logical, so it's not too much of, or actually I should probably use the other delay. So the order in which the blocks are updated, it actually still looks logical for the most part, and it is still also similar to the naive diamond shape, but I think I still would prefer if it would behave differently. But yeah, I did not bother implementing that in this mod, and I think it would actually also be quite difficult. Now, something that I also know that I experimented with, but that is not in this, is the priority of tile ticks. So a comparator has a higher or lower priority than the repeater. So I think the priority value is higher, but it means that it's after the repeater. So this will be a 0 tick always, no matter which lever I use. And I think that, so I guess disclaimer, I'm not really doing Redstone. I just like coding, I guess, and I like the idea of making this mod. But I don't really know what impact certain changes have. So with that being said, I think I personally would prefer if this didn't work this way and the whole priority thing was removed, and this would behave essentially consistently with 2 repeaters, where it depends on the lever that you flick. But yeah, I don't know how important this is. I mean, this in of itself is pretty important, but since there's a pretty easy replacement, I'm not sure how much it matters. And it would just take some cases where this wire has the highest signal strength, and then if it's already the case that this has the lower signal strength when it's being turned on, then it actually wouldn't break, even if the priority was removed. I do remember that initially when removing priority, I had some issues with repeater clocks. They were broken. I think I fixed that, and I also think that it actually made the code a little bit smaller and nicer and more elegant, but apparently it didn't make it in the 1.14.4 version, and maybe the reason for it is that there actually still were some issues with it. I just don't quite fully remember what happened there. Some other changes that I made is, so essentially my sort of take is when they change Redstone and change the update order and inevitably also break some mechanics if they want the update order to be logical and also behave the same to all components, like levers or pistons moving blocks, then they should probably break everything at once rather than having multiple updates that all break things consecutive, like multiple consecutive updates that all break Redstone things. So I also made some more fixes here. For example, if I turn on this lever, you can see that the powered rail actually updates correctly, where it wouldn't do that in the vanilla game. And if you actually look at it, you can see that there's a state called power now, which is set to 5. The vanilla powered rail only has a boolean flag for powered, which is either true or false. So the way I fixed it is I just changed that to be power, and then if I flick this lever, it changes to power 9, which is the maximum distance that a source can power powered rails. And this would also mean that if you would, for instance, place an observer on this rail and just flick this lever, it would detect that change. And the same is also true for activator rails. There are also some other changes that I made, like Redstone redirection causes a Redstone update, and like with the implementation of this mod, this makes a lot of sense. Because as I've shown before, if this is a redstone lamp, which is also lit, which is also lit, no, why? I type T and press tab and it auto-completes false. Then if I just cause a clock update, it doesn't react to it. And from that perspective, it makes a lot of sense that this should just update the lamp. I'm not sure how useful this is. There are quite some other ways to butt, for example, a piston. But for other Redstone components, that's not really possible to do that. So this is like, in vanilla, this is the only way you could have a Redstone lamp which has butt behavior, which I'm not sure how useful this is. I think it's pretty niche, and I think it probably doesn't matter too much. There are some, however, also some things that are actually allowed in conjunction with quasi-connectivity. So for example, if you have like piston wall like this, you could extend this middle piston by applying some pretty actually hard to pull off tricks related to Redstone redirection. And if this is removed, I think there is actually no way this piston could be extended on its own. However, I think this is also not too much of an issue, because I don't really think that there is much of an option to have like a piston grid essentially anyway. So where you could also extend all the other pistons individually. I don't know, there might be some ways to do that, but I don't really know that that would be possible even with the redirection bug. But yeah, so I hope you found this interesting or helpful, and yeah, that's everything that I wanted to talk about. So thanks for watching, and yeah, well, I don't know, there's no update schedule, but maybe if I update again, upload again, I'll see you next time, and until then, have a nice time.